So this problem is about a cake. The only thing we actually know right now is that this very top section here, that surface area is 12.56 inches squared, and that each layer we go down, the diameter increases by 2. So the diameter increases by 2 each layer down. So that's what we know so far. So what we're going to do is we're going to work through this by finding, using our area formula, the area is equal to, what's that going to be, pi r squared. If we can find the radius of this top cake, we can find each layer after that as well. So that's going to be our goal. We're going to plug this in and say 12.56 inches squared. And that will be equal to 3.14 times r squared. If we divide both sides by 3.14, that will go ahead and give us what we're looking for here. So we get that r squared, I'm going to switch the sides here, and I need to pull out my calculator. All right, so now we're ready to get r squared, which is going to be 4. So if r squared is 4, the radius is 2. Now we said the diameter increases by 2 each layer. Since the diameter is twice the radius must increase by 1 each layer. So we have to increase here and here to get what we're looking for. So our radius at the bottom is going to be plus 1 is plus 2. 2 plus 2 is 4. So our new radius, and I'm going to use capital R for that. Our new radius is 4 inches, because that was in inches. And now to find the area, we have to do pi times r squared. So the area is equal to pi times 16, which is going to give us, we'll use 3.14 for pi, 50.24. That's going to be 50.24 inches squared. Now you might be tempted to stop there, but we have to be careful. We found the bottom area of the entire thing, but it really only wants us to find the outside ring. So we need to subtract something from that. The outside ring, if we were looking at it vertically, we'd have a circle, and we're cutting a circle out of it. So we have this circle within a circle, and we're only interested in this outermost area here. So there's different ways we could approach this problem. But the first thing we need to do is think about what we're seeing. So here's the aerial view of our cake, and we want that yellow area. So what we discovered is, if I shaded everything, all of this would give me an area of 50.24. I want to subtract that pink area from 50.24. So I'm going to give these names to help us think about it. So I'm going to call this yellow area, I'm going to call that A for area. That's what we want to find. I'm going to call this A, we'll call it A1 and A2. So A1 is what I want to find, and A2 I need to get rid of. So here's my strategy. If I were to cut out A2 from A1, I would get the area I want. So I'm going to do subtraction. 50.24 minus A2 will equal A1. That's my theory. So let's work through it. I don't know what A2 is yet, but I do know from up here that my radius was 2 right here, and I added 1. So my radius should be 3. So it's going to be 50.24 minus pi times 3 squared will give me A1. So 3 squared is 9. 9 times 3.14 is 28.26. So that's 50.24 minus 28.26 gives me A1. When I go through and work that out and round it, that's what I'm getting the 22 inches squared. So what you have to look at here, and I would have thought from the way the problem was worded that they would want you to round more exactly. But this is the answer that it's showing us here. So we had a couple of points to our problem here. And that would be, I'm just going to go ahead and put the full, that's 21.98 inches squared to the nearest hundredth. So let's look at our strategies. So we started with what we knew. We knew this area. From that, we found this radius here. From that radius, we found this radius, the whole radius of the bottom section. With that, we were able to find the area of the entire cake, including the part that was sitting on it. So that's where we got this 50 from. That's the entire, everything in here. But we realized we only have this part of it, all this yellow section here. We have to get rid of this pink part in order to see that. So we double checked and found our radius for here. And then we did a subtraction. We took the area we'd found, we subtracted the area that was sitting on it to find the remaining area here. And that's all there was to it.